Okay, here we go. This video is intended to help walk you through some problems involving pH and buffers. These are the types of problems you typically find in the clinical laboratory. And specifically what I'm working on is the Unit 3, Section 4 homework for the class Clinical Lab Sciences 2003 at Weber State University, which is the best laboratory science program in the world. So, I'm going to try to make a couple of these videos, hopefully no longer than 4 or 5 minutes each, and that way I can upload them not only to the course website but also to YouTube. So, first question says a solution with a pH of 10 has how many hydrogen ions as pure water? If we're going to assume that the pH of pure water is 7, that means that it is more acidic than a solution with a pH of 10. And remember, the more acidic we are, the more hydrogen ions that we have. So every time I increase a level, like 7 to 8 or 8 to 9, I'm reducing the number of hydrogen ions by a tenth. Or if you want to think of it going backwards, when I go from 9 to 8, that's a tenfold increase in hydrogen ions. Or 8 to 7, that's another 10. So the difference between 7 and 10 is going to be that the solution pH of 10 has 1/1000th as many hydrogen ions as pure water. Or in other words, pure water going from a 10 to 9 to 8 to 7, that's going to be 1,000 times increase in hydrogen ion concentration. So that's more of a conceptual thing. First problem here, and you'll notice on your homework I gave you 3 of these. I've reduced it to just 1 so I could hit this one and show you how to do it. So the equation that you're going to want to remember for this is that the molar concentration of hydrogen ions, and remember that's what those brackets mean, they say molar concentration. So the molar concentration of hydrogen ions times the molar concentration of these hydroxide ions is going to equal 1 times 10 to the negative 14. And that just talks about the balance of these two when we're talking about acids. So to work this problem out, I say, hey, I have 1.9 times 10 to the negative 6. What I was asked to find is that hydroxide ion concentration. It's always equal to 1 times 10 to the negative 14. So to get x by itself, I just take 1 times 10 to the negative 14 and I divide it by my hydrogen ion concentration, which is 1.9 times 10 to the negative 6. And I apologize that that's a little bit small. I hope you can still see what I'm doing. So in my calculator, I'm always cautious to make sure I put things in parentheses. I have 1 times 10, that's the little caret's my to the sign, negative 14, close my parentheses, divided by, and I start my other one, 1.9 times 10, my to the key, negative 6. Close that up, and I get a value like this guy, which is 5.263 times 10 to the negative 9th. And that would be my answer, or the hydroxide ion concentration. So the next problem says convert to hydrogen ion concentration. I'm going to do that the exact same way. So I can write it however I want, as long as I have OH times H equals 1 times 10 to the negative 14. So what I know is my OH. What I don't know is my hydrogen. It's always 1 times 10 to the negative 14. So 1 times 10 to the negative 14 divided by 1.01 times 10 to the negative 7th is going to give you my answer. And this one's really simple, but I want to show you how to do it on the calculator again. So I have 1 times 10 to the negative 14 divided by 1.01 times 10 to the negative 7th. Surprise, surprise, it's 9.9 times 10 to the negative 8. And I'm saying surprise, surprise, because if we look at these exponents and these numbers, we can see that we're getting back to basically that 1 times 10 to the negative 14 idea. But anyway, the answer for this guy would be 9.9 times 10 to the negative 8. And we'd call it good.